Hello there, Mr. Sutton here. I've got the Pre-Cal Honors 3-3 Extra Practice number 2 solutions on adding and subtracting rational functions. To subtract these rational expressions, we must first get a common denominator, and before we can do that, we need to factor these denominators so that we can see which factors we actually need in the LCD. So for the first denominator, I need factors of -8 that add up to +2. Well, 1 and 8's not going to work, but 2 and 4 might work if we had -2 and +4. So I'll write d minus 2, d plus 4. And then for the other denominator, well, this is two perfect squares being subtracted. So I can factor that into basically a plus b, a minus b, which square rooting these things, in this case, that means d plus 4 and d minus 4. So for my LCD, looking through my factors here, I definitely need a d minus 2 from that first denominator. Definitely a d plus 4 that both of them actually end up having, but I only need to write it once because it appears at most once in any of these denominators. And then we also have to hit this d minus 4. So that is our LCD, 3 factors for that one. We're going to multiply each fraction by whatever it needs to get those 3 factors now. That first fraction is missing the d minus 4 piece of this. So I have to multiply this by d minus 4 over itself. We have to do it over itself here because we're really just multiplying by 1, so we're not truly changing the value of anything. And now the other fraction that we're subtracting, that is missing a d minus 2, so let's multiply by d minus 2 over itself. And at this point, I'm going to simplify, and then once I have the same denominator, I can actually subtract these together. So let's simplify by multiplying this out here. So the numerator for this first one, I'm just going to FOIL this out. I'm going to have a d squared, and then after that, we've got d times -4 is -4d, and then we have another one of those. -4 times d is still -4d. Finally, -4 times -4 is 16. And for the denominator, we have just these 3 factors written next to each other, which is basically the LCD that we have up there. Now for this next fraction, I've got d plus 2 times d minus 2. Since these are basically the same thing but with opposite signs, I can use my a squared minus b squared shortcut. So square these two things and stick a minus between them. So we have a d squared, and then 2 squared is going to be 4, so d squared minus 4. Or you could think, okay, I've got a minus 2d and a plus 2d. Those are going to cancel, leaving me with no linear term. Any way you slice it, that's what we end up with up there. And in the denominator, we again end up with d minus 2 times those d plus 4, d minus 4 factors. Now we have a common denominator. So it's time to subtract these numerators together. So I end up with one big fraction with just that common denominator. And now for the numerator, I've got let's just go highest to lowest degree here. We've got d squared and then a minus d squared. So those actually cancel, and I don't have any squareds. Next, I have a -4d minus another 4d. That's -8d. There's no linear terms in the second fraction, so just minus 8d then. And then finally, I have a 16 minus -4. I have to distribute this negative over here. So this ends up being actually 16 plus 4, so that's 20. And at this point, let's just check to see if we can simplify by reducing it all. Now, I could factor a 4 out of this, and that would leave me with a -2d plus 5, but I won't be able to actually cancel that with any of the factors down here, so I might as well just leave this the way it is. For this problem, to add 5 over r plus 7, we need to first get a common denominator. Since the only denominator that's not an invisible 1 on this is this r down here, that is going to be our LCD. So to add these together, I've got the original fraction here, 5 over r. No need to change that since it already has the LCD. 7, however, needs an r in the denominator. So to get that, I can think of multiplying 7 over 1 times r over r, which basically comes out to 7r over r. Now that I've got the same denominator, I can add the numerators and keep the denominator. So I end up with a single denominator of r, and in the numerator I now have 5 plus 7r. Since those are not like terms, the best I can do is write 5 plus 7r, and just leave that the way it is. For this problem, before I can subtract these rational expressions, I need to have the same denominator. So in order to get that, you notice these are actually pretty close together. This second denominator is really just the first denominator times a -1. So what I'm going to do, it's a little bit sneaky here, I'm going to factor a -1 out of this second denominator. So that's going to leave me with a -4 plus a, which I could also write as a minus 4. And at this point, there's a few ways I could go. One thing I could do is I could say, okay, let me get all of these factors in an LCD and multiply this first fraction by a -1 to get the same denominator. I could certainly go that route. But if we're being a little bit more clever than that, one thing you could also do, this -1 basically negates this whole second fraction. So you could think of this minus here and this -1 as canceling each other out and really just giving us a plus 3 over a minus 4. Once we've done that, without even having to multiply this first fraction by anything to get the LCD, we've already got a common denominator of a minus 4. That means that we can just merge this into one big fraction where we have a minus 4 as the denominator, and now we can add the numerators, so a plus 3. Since a and 3 are not like terms, the best we can do is just keep them added like this and call it a day. In order to make any progress on adding these rational expressions, we're first going to have to get an LCD, the same denominator, and we're going to have to factor these denominators to figure out what that LCD ought to be. So let me start by factoring each of those denominators. For the first one, I need factors of -28 that add up to -3. So we got 1 and 28, that's not going to work. 2 and 14 is also doomed. 4 and 7, though, that might work. If we have a positive 4 and a -7, so I'll write x plus 4, x minus 7. Now for the other denominator, that's a little bit more straightforward. We can just factor a 2 out of that, and that leaves me with an x minus 7. For the LCD then, looking at all the factors in my denominators, let me start with numbers out in front. So we're going to need a 2 out in front of everything for the LCD, for this 2 here. We're also going to need an x plus 4 and an x minus 7. And this x minus 7 here also covers the x minus 7 from that second denominator. So this covers everything we need. All right, let's multiply each fraction by whatever it needs to get this LCD. My first fraction has almost everything I need except for this 2 out in front. So I'm going to multiply this one by 2 over 2 so that I get the 2 down here, but I'm really just multiplying by 1 because it's a number over itself, so totally legal, doesn't change the value of anything. Now for the second fraction, I've got the 2, I've got the x minus 7. I need to multiply by the x plus 4 over itself, though, to get the rest of the LCD there. All right, so at this point, let me actually multiply this out, and then we'll have a common denominator that allows us to add things together. So for our first fraction, 5 times 2 gives us a 10 in the numerator, and in the denominator, I'll now have the 2, the x plus 4, and the x minus 7 that I wanted. For the second fraction, I need to distribute this 7 to the x plus 4, so that gives me 7x plus 7 times 4 is 28. And in the denominator, I again have 2, x plus 4, x minus 7, common denominator. Since I've got the same denominator, I can rewrite this as one big fraction over that denominator. And now let me just add the numerators together. So let's go from highest to lowest degree. We've got a 7x over in the second fraction, so that'll be in our numerator. Nothing to combine that with. We also have a 10 plus 28. That gives me a 38. And it doesn't look like I can factor or reduce or do anything else to help myself out here. So this is as simplified as it's going to get. To simplify this rational expression, we have to first make sure we have a common denominator. So taking a look at our denominators and the factors that they have, well, let's start with the numbers out in front, the coefficients. So we know we need a 5 from this 5 here. That's the only coefficient that's not 1. So our LCD should have a 5 in it. And in terms of variables, it looks like we also need an a squared, so we'll put that in there. And it looks like we also need a b from that first factor, but actually a b squared. We're going to go with a b squared because you have to put in the LCD the most number of times that a factor appears in a denominator, and that's twice right here. So b squared. Okay, so now we're going to multiply each fraction by whatever it needs to give it the LCD. So for this first fraction, it looks like we've already got the a squared and at least one of the b's, but we still need a 5 and we need another b in there. So I'm going to multiply by 5b over 5b. And when I do that, I'm really just multiplying by 1, so I'm not changing the value. For this other fraction, we have to multiply by, it looks like just an a squared. That's all that's missing from the LCD. So a squared over itself. And now actually multiplying these out, this first fraction, 5 times 5b, that's going to give us 25b, over, this is going to be 5a squared b squared, just to double check here. And it should have given us that because that was our LCD that we were doing this to get. Now for the next fraction, we've got 7a times a squared. That's going to be 7a cubed. And remember, we're subtracting that whole fraction. And the denominator should again be the LCD that we were trying to get. Since we have the same denominator, we can now just keep that denominator and merge everything into one big fraction. In the numerator, we've got 25b minus 7a cubed. And since those are not like terms, we're going to just have to leave it like that. And it looks like this is as simplified as it's going to get. To subtract these rational expressions, we first need a common denominator. And although they both have h squareds, the commonalities end there. We're going to have to factor these and see what factors we're going to need for an LCD. So factoring the denominators now, for the first denominator, I need factors of 20 that add up to negative 9. So let's see, we've got 1 and 20, that doesn't work. 2 and 10 is not going to work. 4 and 5 works if we have negative 4 and negative 5. So I'll write h minus 4 and h minus 5 down there. Now for the next one, we need factors of 25 that add up to negative 10. Not a whole lot of choices here. We've got 1 and 25, which doesn't even come close to working. And then we've got 5 and 5. If they're both negative 5, then that works. So I can write h minus 5 and h minus 5. I could write h minus 5 squared, but I'll just write it out like this, just so I'm really aware of how many of these h minus 5s I have. Okay, so now I need to generate my LCD. So looking at the factors we definitely have an h minus 4 that needs to be included. And we also have an h minus 5. But now moving over to this other denominator, we have 2 of these h minus 5s. The rule is, if you have a factor that's repeated in one of your denominators, then you have to also repeat it in your LCD. So that means we need an h minus 5 squared in the LCD so that we can handle both of these h minus 5s at the same time. Now that we've got that, let's go ahead and multiply each fraction by whatever it needs to give us this LCD. So for my first fraction, I've got an h minus 4 and one of the h minus 5s already. That means I need another h minus 5 to get this h minus 5 squared. So I'll multiply by h minus 5 over itself. And in so doing, I am just multiplying by 1. So I'm not really changing the value, just giving it a makeover. So, and our other fraction now, we've already got the h minus 5 squared, basically. We need to multiply by an h minus 4 in this other one to get the LCD. So h minus 4, there we go. And now multiplying all of this out, in my first fraction, I've got h minus 5 times 1, so just h minus 5 over all that stuff that was already in the denominator, plus also this h minus 5 here. So h minus 4 and h minus 5 squared. We'll actually write it squared at this point just to save a little bit of space. And now the other fraction, we're subtracting this, and I have to distribute this 5 to the h minus 4. So that's going to be 5h minus 20 up there. And then we have the LCD again in the denominator. Since I've got the same denominator, I can merge this into one big fraction with the LCD downstairs. There we go. And upstairs now I'm going to just subtract the numerators. So let's see here. I've got an h, I've got a minus 5h. So h minus 5h is negative 4h. And then I have a negative 5 minus negative 20. So make sure you use this negative and distribute it here. So negative 5 minus negative 20, that's really negative 5 plus 20, which is positive 15. So there we go. And at this point, we might ask the question, well, can I factor or reduce this at all? And it doesn't look like we can. We can't even factor the numerator at all. So this is as done as it's going to get.